Hi guys, welcome back to my channel. Today I'm going to start a new topic, titration, and I will teach you what is meant by the term titration and how can we crack the titration question in my this video. Let's start about titration. Yeah, this is a physical technique. By using this technique, we can find out the concentration of the unknown substances. For that titration, because this is a physical technique, we have to perform a practical. So the apparatus that needs to perform the titrations are, first of all, have you done any titration in your school, guys? So we need a burette, which looks like this. Look at that. This is the burette. I'm not the artist. I'm trying to draw the burette. This is the burette. This is your burette. And we can fill that burette by using some funnel. You have to keep the funnel like this. Burette normally measure 50 centimeter cube. Yeah, and burette, look, this is the burette. Burette always clamp. Look, we have to clamp the burette with the help of some these are called clamping bars, and this is the stand. That's the stand. You have to clamp the burette. Okay, and we also need some conical floss. This is a conical floss. The volume of the conical floss is 250 mil or centimeter cube, same thing. You have a small beaker, 150 mil or centimeter cube. You will provide it by one more small beaker to carry out the chemicals. One more beaker, 150 mil. So that's the stand, and we have to clamp with the clamp bars. Like, look at that in that picture. You have to clamp it. And we need a pipette. It looks like this. Pipette has marking, and the volume of the pipette is also important. You have different types of pipette, but we can use the 50 centimeter cube pipette. There's a marking. I'm sorry, I don't like this pipette. I will draw one more. Nice. Look at the pipette. This is the pipette. And pipette has a pipette filler. It will be with the bulb one or the roller one. That's the pipette. You can fix the bulb. There's a marking. We have different types of the pipettes. We have 10 centimeter cube of the pipette. We normally use the 20 or 25 centimeter cube. How we know that it's a 25 centimeter cube? There's a mark on the glassware. So we need a pipette filler, 2 beakers, and a conical flask and a burette. Sometime you have to make a standard solution. To make a standard solution, you have to weigh your salt. How can we weigh the salt? You have to take the little amount of the salt in that boat-like structure that's called weighing boat. So this is the balance. That's the weighing balance. And you have all these tare value, put it on the 0, 0, put that weighing board on it. That's the your weighing board, put it on that. And you can weigh any, like 2.3 gram of any salt. You put it to a T, press the T. When you press the T, you'll get 0.00. Now you can start your reading. Okay. Once you weigh a 2.3 gram of any salt, you just transfer that salt into a small beaker. That's your small beaker, guys. Transfer that salt into a small beaker. Any salt, like you can use sodium carbonate or sodium hydrogen carbonate, anything. Yeah, to make a stand solution. Add a little amount of water. Add a little amount of water. So this is the small beaker. Add a little amount of water and the salt, 2.3 grams. So you dissolve all these salt into the distilled water or deionized water. Then how can we make a standard solution? That you have to transfer into one more very important apparatus. I'm drawing. Can you name that one? I want to rub this one. Can you name this one more apparatus? This is how it looks. Look at that. So there is a marking, and the volume of this apparatus is 250. This is nothing but volumetric flask to make the standard solution. First of all, you have to make your own standard solution, and that standard solution we can use to titrate unknown concentration of another solution. So transfer that one, all your liquid, with the help of the funnel. Add the deionized water up to the mark. And always, guys, make sure whenever you are adding deionized water, you check the lower meniscus. This is called the lower meniscus, guys. So suppose this is the marking. That's your volumetric cylinder. This is the marking. You have to fill like this, not on the top side. With the help of your eye contact, check is that on the lower curve end, not on the upper curve end. So this is my volumetric flask. I make a standard solution with the help of the volumetric flask. Now my solution is ready to do the titration with the unknown solution. So now you have an idea. What's the purpose of the titration? Titration is a technique used to find out the concentration of the unknown substances. So titration mainly deals with two solutions. Sometimes a salt is provided and you have to make one solution. So this is a technique where we deals with two different solutions. So there are two different types of titration. One titration is the acid-base titration, and another titration is the redox titration. First, we will start the acid-base titration. Then I will teach you the redox titration. To do the redox titration question, I have to teach you how to balance the equation, what is a redox reaction, then we can do the redox titration, acid-base titration and redox titration. So titration normally contain two solutions. So suppose we are doing today I'm going to teach you how to solve the question based on titration. And today we are doing only acid-base titration. So two solutions definitely will be provided to you. One is the acid, and another one is the base. Or the acid form a salt or base form a salt. So I didn't get it. Okay, no worries, guys. I will come to that point. So two types of titration: acid-base titration. Look at that. Before that. So when acids, we have to focus on acid-base now. Then we will do the redox titration later on. Look at that. When acid, any acid or acids, when react with the base or alkaline solution, bases, they react to form, any idea, guys? Acid, and when combined with the base, we will get salt plus water. And this process is called neutralization. So titration is the technique in which we neutralize the strength of the acid with the help of the base, or the strength of the base with the help of the acid. One more thing, can we use, instead of bases, can we use alkaline solution? Yes, acids plus alkaline solution. What is the difference between a base and an alkaline solution? Any idea? So base is a chemical substance which can accept a proton. Then what's the alkaline solution? Write down the definition of a base. Base is a chemical substance which can accept a proton, H plus ion or a proton. Now, what is an alkaline solution? Alkaline solution is a chemical substance which contain OH minus ion, hydroxide ion. And when you dissolve alkaline solution in water, it gives away OH minus ion. So all the alkaline solution are bases, but all the bases are not the alkaline solution. I will give you the example. Look at that. Don't worry, you have a separate topic of acid and bases. I will teach you what is the definition of acid and a base in terms of Laurier-Bronsted or Lewis constant. Now, so ammonia is a base, is not the alkaline solution. Alkaline solution, what are the alkaline solution? First of all the alkaline solution contains hydroxide ion, OH minus ion. And when you dissolve that OH minus ion, it will give away OH minus ion in water. Okay. Let's see the examples of alkaline substances or alkaline solution. All the group 1 and group 2 metal hydroxides are alkaline solution. Group 1 metals: lithium, sodium, potassium, rubidium, cesium, francium. I'm not using the francium. Francium is the radioactive element. Levi, beryllium, magnesium, calcium, strontium, barium, radon. I'm not using the radon which is a radioactive element. Okay. All these group 1 and group 2 metal hydroxide. You know the formula of the metal hydroxide? OH minus. Okay. I will teach you guys about the positive ion, negative ion, ionic bond. But anyway, group 1 metals, they can give away one electron. They lost one electron, so they have a positive charge. Group 2 metal can give away 2 electron or lost 2 electron, so they got a +2 charge. Now, can we write the formula of group 1 metal hydroxide and a group 2 metal hydroxide? Yes, we can write. For example, what is the chemical formula of the sodium hydroxide? Easy. Sodium hydroxide, sodium hydroxide, which is a base as well as an alkaline solution. Sodium, which is from group 1, and it can give away one electron, so it has one positive charge. Hydroxide, OH minus, 1 minus. So put 1 to this side and 1 to this side. This technique is called crisscross method or simply cancel +1 and -1. So you're getting sodium hydroxide, NaOH. Agree? Now, I will show you what will be the chemical formula of group 2 metal hydroxide. What is the chemical formula of calcium hydroxide? So we know that calcium is from group 2 and calcium will lose 2 electrons easily because it has 2 extra electrons in the outer shell. Okay, Ca 2 plus lost 2 electron. We know hydroxide OH 1 minus. Look at that. So I showed you crisscross technique. Only take 1 and times 1 with the calcium times 2 with OH, not the charges, just the number. So CaOH2. Is that right? No, it's not right, guys. This 2 should be multiply or times with oxygen and hydrogen. Whenever we have a unit, whenever we have more than one element, more than one atom, you have to put bracket and times by 2. So that is the chemical formula of calcium hydroxide. Okay, now we will see some chemical formula of acids, and we will combine some base and acid to get salt plus water. That's the actual technique to figure out the concentration of the unknown substances. Unknown substance can be acid or alkaline solution by using titration technique. Okay. Acid is a chemical substance which can donate which can donate H plus ion or proton. Now, we will write some formula of the acid and what salt it can form when it combined with alkaline solution. Look at that. These are the common acids which we normally use in titration. Can you name the first one? So these are the acids. Name of the acid. Any idea? Yeah, I'm coming. Just I want to rub this part. Guys, listen. These tabular form, which I'm doing now, is very important. You can use this for your first year A-level chemistry and your second year A-level chemistry. You can't see this type of notes in any textbook. Now, acid form, acid gives away H plus ion. What's the name of the acid? Name of the acid, name hydrochloric acid. Now, nitric acid, or some teacher, nitric acid or nitric acid. NiTric acid. Third one, phosphoric acid. Phosphoric. Sulfuric. Carbonic. All acid. Carbonic. Last one, ethanoic. The common name of ethanoic acid is acetic acid. Okay. And we know that acid is a chemical substance which gives away a proton. Look at the overall charge. No charge on HCl. If it gives away H plus ion, what ion left? Cl ion or ions. We will left with Cl minus 1 minus HNO3. It gives away H plus. So you have NO3 1 minus. That's the overall 1 minus. This is overall charge. 1 minus PO4 3 minus, because it gives away 3 proton. PO4 3 minus. It's a tribasic acid. I will teach you what's the meaning of tribasic. Sulfuric acid, it gives away 2 proton. So SO4 2 minus. Carbonic CO3 2 minus, and CH3 is 3 COO 1 minus. You know, guys, any non-metal with a negative charge ends as ide. So suffix is id. Non-metals, these small tips, they're useful when you are writing your examination. Non-metals with negative charge ends as, or with the suffix as IDE, like chloride, oxide, sulfide. So what's the name of the ion? Name of the ion. Name of ions. Name of this ion, chloride. What's O2 minus, oxide? Now look at that one. All these acids, phosphoric acid, sulfuric, carbonic, ethanoic, all these acid guys ends with ic. So look at that one. Acids, all the ic acid with the inverted comma form ATE, salt, or ATE, ion. So I didn't get it. Okay, no worries. So whenever you make a salt with this type of the acid, you name the salt ending with 8, because ic acid always form 8 salt. Like nitric, it form nitrate or nitrate. TRATE, like eat 8, it's end with 8. Phosphoric, phosphate. So I will teach you how to write the formula of sodium phosphate. Phosphate, ic acid always form 8 salt, and the acid which has more oxygen is more powerful acid. So these are the strong acids which we used in our chemical lab. Phosphoric acid form phosphate salt. Sulfuric, sulfate. FATE. Please make a note. Take a picture of this if you can't make a note. Carbonic, carbonic. Last one, sorry, carbonic form, carbonate, sodium carbonate. I will teach you how to write the formula of sodium carbonate. Most of the student, even though they are doing A level, but they struggle to write the chemical formula and balance formula. So carbonic form, carbonate, 8 salt, and ethanoate. Yeah. Does this make sense? Look at that. Ic acid always form 8 salt. Okay. So some student asked me, sir, this is a nitric acid or nitric acid. So what is this one then? HNO3 NO2. Any idea? This is called nitrous acid. And we can name it by using its oxidation state. When I will teach you the redox reaction, I will teach you how to name it. Okay, so look at that one. We have us acid and ic acid. Like all these acids, they have nitrous, phosphorus, sulfuric acid with one oxygen atom less. So one more thing, like ic acid always form 8 salt. And look at that. Ic acid always form 8 salt. Now, us acid, nitrous, Trous, us acid. Us acids form ite ion, ITE, nitrite, nitrate. See, nitrite and nitrate. Sorry guys, I don't have enough space. But anyway, look at the one more thing before I conclude everything. Look at that. NO3, 1 minus is nitrate. NO2, 1 minus is nitrite. This is nitrite. It ends with ite. Nitrate, it ends with 8. Then one more thing. Is that okay? Yeah, look at that. So this is, can you name it? Can you name N3 minus, NO2 1 minus, NO3 1 minus? In the same way we have all this. Can you name these 3 ions? They look very similar. Most of the students are getting confused with N3 minus, NO2 1 minus, and I have decided I have to make one video particularly on this to differentiate. So this is IDE, nitride, IDE. I told you, with the negative charge and with IDE. TRIDE, IDE, nitride. And look, NO2 1 minus, this is nitrite, ITE, NITRITE, and this is nitrate or nitrate, 8 salt. This is 8, this is ide, this is ide. Same thing for phosphorus, phosphite, phosphate, phosphide. Okay. See, today we have learned the definition of the titration, what's the purpose of the titration, and we have seen some picture of the apparatus that we commonly use during the titration. And one more thing, when you do the titration in your lab, you have to add the indicator before you start the titration. I will teach you what is the purpose of titration in my separate video. So guys, and today we have learned the definition of the acid, what is meant by the term acid, what is meant by the term base, and we have seen how to write the chemical formula of the acid and the bases. So I think I want to stop the video here. In my next video, I will teach you how to solve the titration question. Sometimes they will ask to find the concentration of the unknown solution in terms of mole per dm cube or in terms of gram per dm cube. And we have to use the same titration technique to figure out the percentage purity of the chemical substances. Okay guys, thanks for watching this video. Thank you very much. Hi guys, welcome back to my channel. Yeah, today I'm going to teach you titration questions. I've already explained about the titration in my previous video. So I want to focus today how to crack the titration questions. Look at that question. In a titration, 25 centimeter cube of 0.5 mole Dm-3 sodium hydroxide is titrated with 20 centimeter cube of sulfuric acid. Find the concentration of a sulfuric acid. That's the main purpose of the titration. We can work out the concentration of the unknown substances, or concentration which is not given in the question. So how to approach for that question? The basic thing is that you have to write a balanced chemical equation between sodium hydroxide and a sulfuric acid. Look at the balanced chemical equation. That's the first step, guys. NaOH reacts with sulfuric acid, H2SO4, and we know that what happens when alkaline solution react with acid, we will get salt plus water. We'll get salt and water. Look at the formula of the salt. How can we write the formula of the salt? I've already explained how to write the formula in my previous video. One more time, just like a recap. Sodium, we are getting into sodium sulfate. So we know sodium is in group 1, Na plus, and SO4, 2 minus, that's the sulfate ion. Look at that. So take 2 to this side and 1 to this side. So NaOH, sodium hydroxide plus sulfuric acid, we will get sodium sulfate, Na2SO4 plus H2O. How many sodium? Because we have to balance the equation, otherwise you can't get the number of moles. So 2 times, that's fine. And I have to balance 2 here, times by 2. So it's 2:1 ratio. Look, 25 centimeter cube of, so volume of the sodium hydroxide and concentration of the sodium hydroxide is given. Always making a habit that make a small column and write the data which is provided. All right, the sodium hydroxide information is given to you, and acid, sulfuric acid, some of the value is given to you. Always use conc, concentration, conc, C, and number of moles, mole, and wall. Always use this conc, mole, wall for each. Conc, mole, wall. Always work out this first. So concentration of sodium hydroxide is given, which is 0.5. Volume of the sodium hydroxide is given, which is 25 centimeter cube. So work out the N. Mole equals to C times V over 1000. That is 0.5 times 25 divided by 1000. Okay, guys. So 5 times 25 is, how much is 5 times 25? 25 times 5, 25, 2, 125. Yeah. So 125 into 10 to the power of minus 4, or 1.25 into 10 to the power of minus 2. That's the mole of the NaOH. What's the ratio? 2:1. I mean double is to 1, or 1 is to half. So to get the mole of sulfuric acid, I have to divide this by 2. So conc, we have to work it out. Mole, just I will show how to work out the mole. And volume is given in the question, yes, 20 centimeter cube. So moles equals to 1.25 into 10 to the power of minus 2 divided by 2. Yeah, so which is nothing but 0.625 into 10 to the power of minus 2. That's the mole of the sulfuric acid. I just want to rub a little bit the top part only to work out the concentration of the sulfuric acid, guys. Look at that. Use the formula to work out the concentration of the sulfuric acid. Anyone? What's the formula of the concentration? Okay, no worries. Conc, concentration equals to mole over volume. We got the mole. which is 0.0625 into 10 to the power of minus 2, or can we do, okay, no worries, 20 divided by 1000. Move 1000 to the upside. So 0.625 into 10 to the power of minus 2. This is 20 into that 1000 goes up. Yeah. So that get cancelled, that get cancelled. So just I want to wrap some more part of the question. I don't have enough space. You can use your calculator, guys. Normally, I'm not using the calculator. I have a habit of doing this type of calculation. So look at that. So this is 6.25 into 10 to the power of minus 1 times 100 divided by 2. Yeah. So that also cancel. So roughly 62.5 divided by 2. So 1.25. I'm not happy with that. Well, anyway, that's the concentration of the sulfuric acid that we got it. Did I make any mistake? 10 to the power of minus 4. So that's fine. So this is fine. I think look at here. That's the 1000, and this become 10 to the power of minus 3. So look at that one. So 10 to the power of minus 3 and divided by 20. So 10 to the power of minus 3 and 1000 cancel off. So this is 0.625 divided by 20, or you can do 6.25 into 10 to the power of minus 1 divided by 2 divided by 20. Yeah. So look at that. So this is, look at that one. So 6 point, can we do like 6.25 into 10 to the power of minus 1 divided by 20. So that goes up. So this become 6.25 into 10 to the power of minus 2 divided by 2. So which is nothing but 3.125 into 10 to the power of minus 2 mole dm minus 3. Please copy down that one and use your calculator, guys. It's so simple to use your calculator. Okay. Look at this question, guys. So concentration of the sodium hydrogen carbonate and a volume of sodium hydrogen carbonate is given to you, and the volume of acid is given. So we have to work out the concentration of the acid. So I tell you, the first thing is we have to write the balanced chemical equation between sulfuric acid and sodium hydrogen carbonate and a HCO3. Acid plus carbonate, acid plus any carbonate, we will get salt, Na2CO3 plus water plus carbon dioxide gas coming off. So look at that. That's the 2 sodium, so balanced by 2 here, and 2 carbon. How many water molecule? 2 water molecule. Check that equation is balanced or not. Sodium. Why the sodium carbonate? We will get sodium sulfate, Na2SO4. Now everything is balanced. Now 1:2 ratio, and I told you make a small column and like a tabular form and do same thing. Write acid here and alkaline solution, but this is a salt of the alkaline solution, a base, and is in the form of salt. That's the sodium hydrogen carbonate, which is a kind of alkaline salt. So CnV, CnV, 25 centimeter cube, 25 centimeter cube. Wall is given, conch is given, not 0.1. You have to figure out the number of moles. So N equals to C times V over 1000, which is nothing but 0.1 times 25 divided by 1000, which is nothing but 2.5 into 10 to the power of minus 3 moles. Yeah. Now we have to work out the mole of acid by looking this equation. Look, what's the molar ratio, guys? 1:2 means 1 mole of acid react with 2 mole of sodium hydrogen carbonate. So can I divide by 2 to get the mole of sulfuric acid? Yeah, because it's 1:2 double ratio, 1:2 ratio. Divide 0.5 divided by 2 to get the mole of this sulfuric acid. Look at here. Mole of the sulfuric acid. So 1:2. So 2.5 into 10 to the power of minus 3 divided by 2, or 25 into 10 to the power of minus 4 divided by 2, which is 12.5 into 10 to the power of minus 4. That's the mole of sulfuric acid. Now volume is given, which is I think 20 centimeter cube of the sulfuric acid. So conch of the sulfuric acid, conch equals to mole divided by wall. What's the number of mole? 1.25 into 10 to the power of minus 3. So I move one decimal to this side, I cancel 10 to the power of minus 3 to 10 to the power of minus 4 to 10 to the power of minus 3. Better you use the calculator, guys. Over 20 divided by 1000. That 1000 goes up. So 1.25 into 10 to the power of 3 times 1000 divided by 2. Is that 6.25? So this is nothing but look at that. You can better use the calculator. 6.20 when you divide by 2. Look at that. 1.25 into 10 to the power of minus 3. That 1000 goes up. So this 10 to the power of minus 3, that 1000 cancel off. 1.25 divided by 20, which is equals to 0.0625. Figure out, guys. 1.25 divided by 2 equals to 0.625 divided by 10. So I'm right. So that's the concentration in mole per dm cube. but the answer we have to get in gram per dm cube. I already discussed in my previous video how can we change mole dm minus cube to gram dm minus cube. Look at that one. That's not the actual answer. So mole dm minus 3 to gram per dm cube. Look at that. Gram concentration time mr equals to gram per dm cube. Concentration is equals to 0.0625 into mr of sulfuric acid is 98. You just figure out, guys, or use the calculator. How much is that? Which is equals to 6.125 gram. Yeah. Look at the answer of that question, guys. So is that clear? In that question, you have to change mole per dm cube into the gram per dm cube. Please watch my previous video on the concentration. I showed you how to convert mole per dm cube to the gram per dm cube. So we got conc in, that's the concentration in mole per dm cube. If you times by its mr, you will get the gram per dm cube. So is that okay, guys? Please copy it on that one. So did you get this question, guys? We will do some more question based on the titration. We can work out the purity of the compound or percentage purity of the given compound by using titration technique. Even we can work out the number of the water molecule attached to hydrated salt. And I have one more question, like a back titration. I love the back titration question. I've seen this back titration question in many past papers, even though they are not there in the textbook. But I come across these back titration question. So we will do that percentage purity question and number of the water molecule attached and a back titration in my next video soon. So thanks for watching this video. I want to wind up here. Goodbye, guys. Hi guys, welcome back to my channel. Today I'm going to teach some more questions of titration. Look at that. We have done the titration and I've already explained you what is meant by the term titration. Why we use the titration. This is a physical technique which involves both acid or base, or sometimes we can use a redox type of titration to figure out the concentration of an unknown substance. Yeah, I have already shown you how to make the standard solution. We can make our own standard solution and we will use that standard solution to titrate the unknown substances and work out the concentration of the unknown chemical. So I like this question. It's a type of titration question. Look at that question. I have taken this question from the OCR textbook and I like this question. It's a kind of titration question. So with that, we can work out the MR of the unknown substances, and unknown acid is given to you and we have to find out MR of this acid. Let's start that question. Look at that. A student dissolve 2.8 gram of an acid which is unknown. He dissolve in a beaker, like small beaker. He dissolved 2.8 gram and transfer that into a volumetric flask and made a solution up to 250. Okay. After he made a solution, he used only 25 centimeter cube of this solution. Look at that. Solution up to 250. the student titrated 25 centimeter of this acid against sodium carbonate. Okay, so this look like a straightforward titration question. Okay, now, so the first question is find out the number of moles of sodium carbonate used for this titration. Okay, moles of the sodium carbonate, moles of Na2CO3. Can we work out the moles of sodium carbonate? Yes, guys. Look at that. We have a concentration of the sodium carbonate and we have a volume of the sodium carbonate. Whenever you have a concentration and a volume, the first step is work out the mole. Okay. Mole equals to C times V over 1000, which is 0.05 into 20 divided by 1000. Okay, so that get cancelled. Okay, can I write one more time here because I don't have a space here. So 0.05 times 2 divided by 100. Yeah, when you work out, we will get 0.001 or 1 into 10 to the power of minus 3 moles of sodium, moles of Na2CO3. Now look at that. Can we work out the mole of this acid, guys? Yes, we can work out. Look at the molar ratio, 1:2. So you have to just double it to get the moles of the unknown acid HX. You just double it because 1:2 molar ratio. So moles of HX 2 into 1 into 10 to the power of minus 3. That's nothing but 2 into 10 to the power of minus 3. That's the mole of HCl, HX, my bad, when we use only 25 centimeter cube. But the student made a solution up to 250. So that's the number of moles of an acid HX for only 25 centimeter cube. Can we work out the mole of the acid for 250? Yes, we can work out the mole of the acid for total volume of the acid that the student made, which is 250 centimeter cube. Okay, how can we do it? Just times by 10. This is the mole for 225. So that's the mole for 25 centimeter cube. And we have to work out for 250. So you have to times by 10. Moles of HX for 250. 2 into 10 to the power of minus 3 times by 10, which is nothing but 2 into 10 to the power of minus 2. That's the mole of an unknown acid which is given in the question. So for 250. So 2 into 10 to the power of minus 2 is the mole of an HX. From that mole, can we work out its MR? Yes, we can work out its MR. 2.8 gram of the acid was used by the student to make 250 centimeter cube of the solution. So that's the mole. How can we work out the mole in terms of the mass? Look at that one. Mole equal to mass over MR. So rearrange that formula. So moles equals to, I like this question. That's a nice question, guys. That's a nice question. So mole equals to mass over MR. I want to work out the MR. So rearrange it. So MR of an acid HX equals to mass divided by its mole. Mass is 2.8 gram. So 2.8 gram and that's the mole of an acid. Look at the mole of an acid, which is 2 into 10 to the power of minus 2. Look at that one. Okay. So mass is 2.8 gram divided by 2 into 10 to the power of minus 2. 2.8 is nothing but 1.4 into 10 to the power of 2. Yeah, that 10 to the power of minus 2 goes up. So is equals to 140. That's the MR of an acid, which is HX. Okay. Copy down that one, please. Look at this question. Yeah, it looked very lengthy question. And this is more worded question. It is a simple question, but this is more worded question. Look at that. So a student dissolved 2.10 gram of sodium hydrogen carbonate. He dissolved it in a small beaker. That's 2.101 gram. And transfer that one into the volumetric flask and made a solution up to 250 centimeter cube. And from that 250 centimeter cube, he only used 25 centimeter cube pipette out and transfer into the conical flask to start the titration. Before he started his titration, he added methyl orange, which is an indicator, which helps to show the endpoint. I will teach you what is the use of indicator, different types of the indicator in my future video. Now, in the conical flask, he added this sodium hydrogen carbonate, 25 centimeter cube, and added a methyl orange. Now, he titrated this with acid. Which acid? Hydrochloric acid. And he got a tighter volume of 25.9 centimeter cube of acid. What's the question? What we have to figure out? We have to work out the concentration of an acid, hydrochloric acid, in gram per dm cube. We can work out in mole per dm cube than in gram per dm cube. So the first step, how to approach that question, work out the mole of sodium hydrogen carbonate is given. We can easily work out the mole because you have grams. Yeah. So what's the formula to work out the moles? Mole equals to 2.10 divided by 84, 23 plus 1 plus 12 plus 48. I think it's 84. So work out the 84. When you divide, so 2.10 divided by 84. 84 is the MR of sodium hydrogen carbonate. When you divide that by, you will get 0.025. That's the mole of sodium hydrogen carbonate. And this is the mole for 250, guys. Why? We made a solution up to 250. Yep. So you have to work out the mole for 25. How can we work out? So you have to divide it by 10. Yeah. Mole of the sodium hydrogen carbonate for 25. So mole of NaHCO3. This is 0.425 equals to 0.025 divided by 10. Why divided by 10? That's the total mole, but we only use 25. So that's the mole of sodium hydrogen carbonate for 25 centimeter cube of the acid. I want to rub this part only. I don't have enough space. Look at that. That's the number of moles of sodium hydrogen carbonate for 25, which is moles of NaHCO3 for 25 equals to 0.00, yeah, one more 025, guys. Is that okay? 0.0.0225. Okay, that's the mole of sodium hydrogen carbonate for 25. Can we work out the mole of HCl? Yes, you can easily work out the mole of HCl. What's the molar ratio? 1:1. So that's the mole of HCl, because the ratio of HCl and sodium hydrogen carbonate is 1:1. Okay. The moles of HCl equals to, because the molar ratio is 1:1, moles of HCl equals to 0.0025. Fine. Okay. And when we neutralized, we got this volume. That's the volume of HCl. Can we work out the concentration of HCl by using this volume? Yes, we can work out. Okay, we can work out the concentration of HCl by using that many moles. What's the formula to work out the conc? Conc equals to concentration equals to mole over volume. How much is the mole? 0.0025 divided by volume, which is 25.9 divided by 1000. Why 1000? I want to change that into centimeter cube into the dm cube. Look at that one. So which is equals to 0.0965 mole per dm cube. Yeah, but that's not the question. The question is calculate the concentration of HCl in gram per dm cube. That's in gram per dm cube. Look, that's the gram per dm cube, and this is mole per dm cube. So how can we change gram per dm cube, mole per dm cube to gram per dm cube? So conc time mR of HCl gives you gram per dm cube. So times this value by mR of HCl. What's the mR of HCl? HCl, hydrogen 1, chlorine 35.5, which is 36.5. So when you work out, so just I want to rub that one. So conc time mR, you will get the quantity in gram per dm cube. Look at that. What's the conc? Conc is 0.0965 times 36.5 equals to 3.25 gram. Okay. Yeah, that's quite a nice question. I want to stop here. You look at that. 0.0965 times 36.5. I've mistakenly written something. So when you do that one, the answer is 3.52 gram dm minus 3. So that's quite interesting question. So we can work out one more question. Yeah. Look at this question. It's a simple, very simple question. You want to try as a homework, or can I try it now? Okay. So look at that one. Sodium carbonate versus HCl. So first of all, I told you a million times, guys, you have to write a balanced chemical equation to start your titration question. First and foremost thing is balanced form of chemical equation when a sodium carbonate react with HCl. So sodium carbonate, Na2CO3 plus hydrochloric acid, we will get sodium chloride plus H2O plus carbon dioxide. Any carbonate, when react with acid, we will get salt, water, and carbon dioxide. How many sodium, guys? 2 sodium. How many sodium? 1 sodium times by 2. How many chlorine here? 2 chlorine. So I have to times by 2. Yeah. That's the beauty of the reaction. If you miss the balancing, you can't get the exact number of moles. If you can't get the exact number of moles, then you can't figure out the concentration of the HCl. Okay, that's the equation. That's the first step. Step 2, I told you, write the data in the like a column form or in the tabular form. Like acid, here we have acid and sodium hydrogen carbonate. This is the salt of alkaline solution. Why this is salt of alkaline solution? I will tell you in my future videos. Look at that. Conch, I always told you, use the conch mole wall. Concentration mole wall for both. So concentration of sodium carbonate is given, which is 0.2. Okay. And the volume of the sodium carbonate is given 25 centimeter cube. So work out the mole of the sodium carbonate. Mole easy. Mole C V and mole. Mole equals to some teacher use N. It doesn't matter. You can use N. N or mole equals to C times V over 1000, which is nothing but 0.2 times 25 over 1000, which is nothing but 5 divided by 1000, which is 5 into 10 to the power of 3 mole. Yep. Look at the molar ratio. 1:2. So to get the mole of the HCl, you have to double it. So double that one. 2 into 10, 2 into that, just double the mole. 5 into 10 to the power of -3 or 1 into 10 to the power of -2. That's the mole of the acid. Which acid we use? Hydrochloric acid. Can we work out the conch? Check whether the volume of the HCl is given. Yes, it is given 20 centimeter cube. Conch equals to N over V. What's N? 1 into 10 to the power of -2. Just now we worked it out. Divided by 20 divided by 1000. Why 1000? You have to always change centimeter cube to dm cube. So can I rub this part, please? Yes, sometimes we may expect the easy titration question. Don't always expect the titration question in terms of percentage purity. Yeah, it will come in the examination. So conch equals to 1 into 10 to the power of -2 divided by 20 divided by 1000. So you can move the 1000 up, which is 1 into 10 to the power of -2 times 1000 divided by 20. That cancel. So this 10 to the power of -2 and 100 cancel off. And if you think I confuse you, use the calculator. Best thing, use the calculator. So 1 divided by 2. This 2 0 cancel, that 2 0 cancel. 1 divided by 2 is nothing but 0.5 mole dm -3. But that's not the question. The question is that you have to convert the mole dm -3 into gram per dm cube. So how can we convert this mole dm -3 into the gram per dm cube? Look, conch, concentration time mr equals to gram per dm cube. This is the formula, guys. So remember that formula. Conch time mr. What is the conch? You got the conch. Conch time mr. Yeah. See, one thing, try to memorize all these concepts in the chemistry. Try to learn it. Learning chemistry is a fun, guys. When you are trying to memorize the chemistry, it muddle up everything. So learn the concept slowly. I will teach you everything. So hope that will work. Okay, look at that one. So 0.5 time mR of sulfuric acid is 0.5. It's easy to work out the, sorry, mR of hydrochloric acid. It's easy to work out the mR of hydrochloric acid, 1 plus 35.5. So can you work out what's the answer? So I will leave here. Okay, how much is that? Just half it. It's 18.25. Yep, that's gram per dm cube, guys. Gram dm minus 3. So I want to stop my lesson here. I will come back in my next video with the percentage purity question and the back titration. Okay, guys, thanks for watching this video. Good to see you. Thank you. Bye. Hi, guys. Welcome back to my channel, guys. Look, today I'm going to teach you a new question based on a titration. In that question, we are going to crack the percentage purity of impure substances by using a titration technique. Why I have chosen this question? Because I have seen this type of question in many past papers. So guys, I think you have only 3-4 weeks left for your final examination. Please focus on your examination. Don't waste your time. That's the best time to do more revision. And after this week, you have half term coming up. So utilize that time and do more revision on that. And if you have any question regarding the chemistry, or any question from the past paper, please get back to me, and you can text me or email me your question on my channel. Okay, let's see this question. Yeah, look at that. This is 2.5 gram of impure sodium carbonate was dissolved in pure water. Yeah, 2.5 gram of impure sodium hydrogen carbonate was dissolved in pure water. Don't get confused with the pure water. This is deionized water, and the volume made up to 250. Let's start the question. So we have 2.5 gram. You can weigh the 2.5 gram of sodium hydrogen carbonate, which is impure NaHCO3, dissolve in pure water or deionized water. Actually, that's the deionized water. There's no pure water. So, and transfer that into a volumetric flask and made a solution up to 250. Okay, that's our first step. You know that after that, you pipette out 25 centimeter cube into the conical flask and titrate that 25 centimeter cube of this solution with sulfuric acid. Sulfuric acid we have to fill in a burette. Okay, I know this look very lengthy question. It's just wording, guys. When you crack down in that way, it's easy to solve this question. I always told my student, try to visualize that by a small drawing. So that will definitely help you to crack this question. Look at that, it's so simple. We don't want all these worded information. We just need a few information. That's the 2.5 gram of impure sodium hydrogen carbonate. We know that sodium hydrogen carbonate is not pure in terms of this question. My first question, my question is that can we use 2.5 gram of impure sodium hydrogen carbonate to work out its mole. Anyone, guys? No, we can't use 2.5 gram to work out its mole. We know that this is impure. I don't know how much impurity is there with sodium hydrogen carbonate. To figure out its actual mass, we are using a titration technique. With the help of a titration technique, you can figure out the mass of the pure sodium hydrogen carbonate. Okay, so I showed you we are using sulfuric acid to figure out the moles of sodium hydrogen carbonate. Look at that. We don't need all these worded question. We just need this information. If you don't mind, can I rub the board? Yeah. So I already explained a little bit here. So we can jump over the calculation. So let me write few things here. What are the few things we want? Impure mass, which is 2.5 gram, and we made a solution up to 250. We want a volume of sulfuric acid, which is here, and a conch of sulfuric acid. That's it. An equation between sodium hydrogen carbonate and sulfuric acid. Okay, guys. This is the impure mass of sodium hydrogen carbonate and the conch of sulfuric acid. I'm going to write one more time. Conch of sulfuric acid and the volume of the sulfuric acid, what we got at the end of the titration. Okay. Look at the wall and conch. So the first step is to work out the mole of the sulfuric acid, which is mole equals to C, conch of sulfuric acid, time volume of the sulfuric acid divided by 1000. Okay. 0.05 time 28.3 divided by 1000. Okay. Look at that. When you do the calculation, you will get this many moles of sulfuric acid. To work out the mole of sodium hydrogen carbonate, I have to write its balanced chemical equation. Okay. So conch, we know conch of sulfuric acid and a volume of the sulfuric acid. If you don't mind, can I rub the question? This part only. Yeah. So I have all the information. We don't need this one. Guys, always this is the easy way. When the question is very lengthy, break down into simple way. Or try to visualize by using little drawing. Let's see. So a balanced chemical equation. Look at the balanced chemical equation between the sodium hydrogen carbonate and sulfuric acid. Sodium hydrogen carbonate plus sulfuric acid. When a carbonate react with any carbonate react with acid, you will get salt, Na2SO4, sodium sulfate, plus carbon dioxide gas, plus water. So look at that. How many sodium? 2 sodium times by 2. What's the molar ratio? 1:2. So you got this mole of sulfuric acid. To get the mole of pure NaHCO3, you have to times by 2. Mole of NaHCO3 equals to 1.415 into 10 to the power of minus 3 times by 2. Okay, now look at that. Sorry guys, look at that. Okay, now 2.83 into 10 to the power of minus 3 is the mole of Na2CO3, NaHCO3 for 25. We titrated 25 centimeter cube of sodium carbonate. But initially, we made a solution up to 250. So work out the mole for 250. How can we work out the mole? Times by 10. So moles of NaHCO3 for 250 centimeter cube equals to 2.83 into 10 to the power of minus 3 times by 10. Okay, now look at that one. So how much is that? 2.83 into 10 to the power of minus 2. Okay, we got the mole of pure NaHCO3. Now, can we use this mole to work out the mass of pure NaHCO3? Yes, why not? Mass of, this is the mass of the impure. I still did not clear that one so that we can use this value to figure out its percentage purity. So mass of the pure sodium. Now look at that. That's the mole of pure NaHCO3 for 250. Now, mass of pure NaHCO3. Look at that one. Mass of pure NaHCO3 mole time its MR. How much is the mole? 2.83 into 10 to the power of minus 2 time, work out the MR of sodium hydrogen carbonate, 23 plus 1 plus 12 plus 48. So it's equals to 84. Yeah. Now, when you time this to, see what you will get. You will get the mass of pure sodium hydrogen carbonate. Let's the mass of the pure sodium hydrogen carbonate. Yeah, you use your calculator, which is nothing but 2.83 into 10 to the power of minus 2 times 84, which is equals to 2.37. That's the mass of pure sodium hydrogen carbonate. Look at that. Mass of the pure sodium hydrogen carbonate, mole time its MR, which is 2.37 gram. That's the mass of pure one. And look at the mass of impure one. So what's the formula to work out the percentage purity? Easy one. Percentage purity equals to mass of pure divided by mass of impure time its 100. Always percentage means you have to times by 100, which is nothing but 2.37 gram divided by 2.50 gram. Guys, impure is always bigger than your pure one, obviously, times by 100. When you work it out, you can use your calculator. The answer is 95.1 something percent. So this is the way you can figure out percentage purity of any chemical substance. We can use a titration technique to answer this type of question. So thanks for watching this video, guys. I will come again. Look at this question. It's a type of hydrated salt. I've seen this type of question in many past paper, guys. Look, they will ask you to work out the number of mole of water molecule attached to hydrated salt. First of all, normally we have two types of salt: hydrated salt and anhydrous salt. Anhydrous salt has no water molecule attached to it. And hydrated salts are those, some are those to which some of the water molecule are attached as the integral part of the salt, so that its amount increases. This is called hydrated salt. And hydrated salts have a definite shape. That's why we call them as a crystalline salt. Now, the mass of the hydrated salt is given to you, which is sodium carbonate. And that sodium carbonate, hydrated one, we dissolve in water. Like, take little amount of hydrated salt. How much hydrated salt is given to us? Look at 2.86. We take 2.86 gram and make a solution up to 250, and made a solution up to 250. Okay, that's the solution of only sodium carbonate. Why, sir? When you dissolve the hydrated salt, this part, which is the integral part of the sodium carbonate, also dissolve and form a water molecule. So that's the solution of only Na2CO3. This solution we are titrating with known concentration of HCl. Yeah, so concentration of HCl is given, volume of HCl is given. So the first step is to solve this question is that you have to work out the number of moles of acid given. So guys, if you don't mind, because I'm really sorry, I don't have enough space, can I rub this part here, the top part? I know how much salt we have taken, 2.86 gram. Okay then. And you have to work out the number of moles of HCl used. Work out the number of moles of HCl used. Look at that. Mole of HCl, mole equals to C times V over 1000. Okay. Look at that. What's the conc of HCl is given in the question? 0.1. So 0.1 times 20 divided by 1000. So this cancel. 2 into 10 to the power of minus 3 mole of HCl. Okay. To work out the mole of only sodium carbonate, we have to write the balanced chemical equation between the sodium carbonate and HCl. Balanced chemical equation between the sodium carbonate and HCl. Okay. Balanced chemical equation between the sodium carbonate and HCl. Okay. Look at that. Any carbonate, when react with acid, we will get carbon dioxide, salt, and water. React with acid, we are getting NaCl plus H2O plus carbon dioxide gas coming out. How many sodium we use here? 2. And there's 1 sodium times by 2. How many chlorine? 2 chlorine, so times by 2. Look at the molar ratio, 1:2. We got the mole of sodium, we got the mole of HCl. To get the mole of sodium carbonate, we have to divide this by 2. Now, the moles of only Na2CO3 equals to, look at that, can I divide this mole by 2? 2 into 10 to the power of minus 3 is the mole of HCl divided by 2, 1 into 10 to the power of minus 3. Whatever the mole you got, this is the mole for 25 centimeter cube, because we no doubt we made a solution up to 250, but we only used 25 centimeter cube and titrated with HCl. So these are the moles of sodium carbonate for 25 centimeter cube. Mole of Na2CO3 for 250 centimeter cube. So you have to times by 10. 1 into 10 to the power of minus 3 times by 10, which is equals to 1 into 10 to the power of minus 2. With that mole, what can we do next? With that mole, can we work out the mass of only Na2CO3? Mass of sodium carbonate. Yep. Can we work out the mass of sodium carbonate? Yes, why not? So mass equals to mole time. It's Mr. Look at that. Sodium carbonate and Mr. Na2CO3. 23 times 2 plus 12 plus 48, which is equals to 106. So mass of only Na2CO3 equals to mole time its Mr. Mole 106 times 1 into 10 to the power of minus 2, 1.06 gram. We got the mass of only Na2CO3, and we know the mass of hydrated salt. What's the mass of hydrated salt? Mass of hydrated salt, which is given in the question, hydrated salt Na2CO3 NH2O equals to 2.86. Agree? Yeah. Now I want to rub it. See guys, I'm keep on telling, I have seen this type of question or similar to that in many past paper. Paper 1 for OCR at EDEXCEL AQA. Okay, now look at that. Mass of hydrated Na2CO3 NH2O equals to 2.86 gram, which is given in the question, and we just work out the mass of the pure Na2CO3. Mass of only Na2CO3 equals to 1.06. If you subtract that two masses, we will get the mass of NH2O. Mass of NH2O equals to 1.8. Work out. You'll get 1.80. 1.8 gram. That's the mass of NH2O. After that, how can we crack a number of molecules of water attached? Okay, use the technique of finding empirical formula. So you have to work out the molar ratio of sodium carbonate and water molecule. Okay, look at that. Masses, we have masses, so we will work out the molar ratio of sodium carbonate and NH2. So moles, look at that. We have Na2CO3 versus NH2O. The masses is given, mass over its Mr. No, we found out the mass of sodium carbonate. We worked out the mass of sodium carbonate, and its Mr equals to 106. Work out its molar ratio. We worked out the mass of water, 1.8, and the AR of Mr of water is 18. How's that? 1 times 2 hydrogen plus 16. Okay, work out. Now look at that. This is 0.01. This is 0.1. So what's the molar ratio of sodium carbonate and H2O? 0.01 is to 0.1. Now use the technique of empirical formula. So divided these two numbers with the smallest number, that is 0.01 and 0.01. This is 1, this is 10. So what is the number of moles of water molecule attached? N equals to 10. That was our question. N equals to 10. Look at that. Very similar questions will come up in the redox titration also. Mainly redox titration is between ferrous sulfate and KMnO4. So hydrated ferrous sulfate will be given to you. In the hydrated ferrous sulfate, you have to work out the number of water molecule attached to ferrous sulfate. So by this way, you can easily work out how many water molecule attached to a particular salt, which make this salt as hydrated salt. Look at this question, guys. This question is based on back titration. First of all, how can we use back titration to figure out the percentage purity of impure substances? I will explain you. In a back titration, you will get impure substances or the alloys. With the help of the back titration, you can figure out the mass of the pure substances present in impure substances. This is a type of that question. Or sometimes they will give you alloy and you have to figure out the percentage of a metal in a respective alloy, like copper alloy. You have to work out the amount of the copper in bronze. So see that question. I like this question. This is my one of the favorite questions. I have seen this question in many past papers. That question comes in AQA, OCR, AQA, OCR, EDEXCEL in many past papers. Okay. Here, impure limestone is given to you and some mass of limestone is given to you. Calcium carbonate plus some impurities with the pure form of calcium carbonate is called limestone. Limestone is nothing but the chalk. You know the white chalk teacher used to write on the blackboard. So we have to work out the amount of calcium carbonate present in the given limestone. I'm just explaining you. You can read that question. Here, in this type of back titration, we are using excess of HCl. When you use the excess of HCl, some amount of HCl, look at that, HCl is in excess. This HCl is in excess. First, we crush the limestone into small pieces, and that limestone we are going to react with HCl. When you add HCl to the crushed limestone, you will definitely get carbon dioxide gas. So after that, you have to wait. Look at the question. Was left until all the bubbling stop. Bubbling of carbon dioxide stop. So look at here. So you crush the limestone into pieces. Then that's my limestone. And we are adding excess HCl. When you add HCl to the limestone, you have a reaction with bubbling of the carbon dioxide gas. I'm writing the reaction. Sorry, I don't want to write the reaction because that's a limestone. This is not the pure form of calcium carbonate. Anyway, you transfer, you have to wait till all the bubbles of carbon dioxide cease down and transfer that into a volumetric flask and made a solution up to 250. That was given in the question and was then made up to 250. This 250 centimeter cube of a solution, then we will titrate with sodium hydroxide. Pip it out 25 centimeter cube and titrate it with sodium hydroxide. Why we are titrating this solution with the sodium hydroxide? Anyone? What's the purpose of using sodium hydroxide? Look at here. Sodium hydroxide of a concentration was added from the burette. 30 centimeter cube of sodium hydroxide were needed. Anyone? What's the purpose of sodium hydroxide used here? See, I told you HCl is in excess. So look at that. CaCO3 plus 2HCl. We are getting calcium chloride, CaCl2 plus CO2, okay, plus water molecule plus H2O. This hydrochloric acid is in excess. So the hydrochloric acid, which is in excess, some part of the hydrochloric acid react with calcium carbonate and some part left in the solution. To figure out the amount of the HCl which is left in the solution, we will titrate with the sodium hydroxide. That's the question, guys. So the amount of the HCl which is unused, it means left out in the solution, will titrate it with sodium hydroxide. That is why this is called back titration. Okay, I know the mass. What mass, if you don't mind, can I rub? The mass of the limestone is 1.25. If you don't mind, can I rub the question? Yeah. Okay. Is this question clear to you? So look at that. We are using excess of HCl. A concentration of HCl is given, and the volume of HCl is given. So conc of HCl is 1.0 and volume is 50. So with that, you can figure out the number of moles of HCl used initially. So moles of HCl used initially, mole of HCl. Mole of HCl equals to C times V over 1000. What's the C? 1 into 50 divided by 1000. How much? 5 into 10 to the power of minus 2 moles. So that's the initial moles of the HCl used. Okay. Now, some of the HCl reacted with the sodium carbonate. Some of the HCl reacted with the calcium carbonate, and all the impurities which is present in the limestone settle down in the solution. Because in that question, it is titrated with HCl. So all the impurities dissolve. Now we have to write one more equation to figure out the amount of HCl left out in the solution as a mixture. Now, with the help of the conc of NaOH and the volume of NaOH, we can also find out the number of moles of sodium hydroxide. Moles of sodium hydroxide, mole of NaOH equals to C times V over 1000, which is 0.1 times 30 divided by 1000. So look at that. This cancel, 3 into 10 to the power of minus 3 moles of NaOH. We got 3 into 10 to the power of minus 3 moles of NaOH. Number of moles of sodium hydroxide, 3 into 10 to the power of minus 3. So to work out the mole of HCl, which is unused, we have to write one more balanced form of a chemical equation. That's why we name this titration as a back titration. So number of moles of HCl, which is left out, HCl plus NaOH, simple acid-base reaction, we will get salt plus water, NaCl plus H2O. Okay, now this is the mole of NaOH. Look at the molar ratio, 1:1. So the same mole for HCl. The moles for the HCl, 3 into 10 to the power of minus 3. That's the moles of HCl left out in this solution. 3 into 10 to the power of minus 3 moles of HCl unused or left out into the solution. But this is the mole for 25, and we made a solution up to 250. So work out the moles of HCl for 250 moles of HCl for 25. That's for 25. For 250 centimeter cube, 3 into 10 to the power of minus 3 times by 10. That's the mole of HCl for 250 centimeter cube. Now, that's the mole of HCl left out in this solution. And we know the initial mole. Guys, these are the initial mole of the HCl. Okay. Now, so 3 into 10 to the power of minus 2. That's the mole of HCl left out in the solution. So how much mole of HCl used to react with calcium carbonate? Look at that. Initial minus unused. 5 into 10 to the power of minus 2. That's the initial mole of HCl. Minus 3 into 10 to the power of minus 2. That's the number of moles of HCl left in the solution. How much left out? So 2 into 10 to the power of minus 2 moles of the HCl actually reacted with calcium carbonate. Okay. I rub the equation between the calcium carbonate and HCl. I will write it again. Don't worry. Sorry for repeatedly rubbing the board because I don't have enough space. Now look at that. CaCO3 plus 2HCl will give CaCl2 plus water plus carbon dioxide gas. What's the molar ratio? 2:1. So we got the number of moles of HCl reacted with calcium carbonate, which is 2 into 10 to the power of minus 2. Okay, to work out the number of moles of calcium carbonate, we have to divide by 2 because it's a 1:2 molar ratio. So moles of CaCO3, pure form of CaCO3, that is only reacted. Moles of CaCO3 equals to 2 into 10 to the power of minus 2 divided by 2, i.e. 1 into 10 to the power of minus 2. This is the mole of pure form of calcium carbonate. With that mole, can we work out its mass? Yes, why not? We can work out the mass of pure CaCO3. Mass of pure CaCO3. Mole time, it's Mr. Mole time, it's Mr. Okay. What is the Mr of calcium carbonate? Take calcium as 40. Ar of calcium is given in the periodic table as 40.1. I don't want to take 40.1. I just want to take 40 to get easy calculation. Okay. Look at the Mr of CaCO3. CaCO3 4A plus 12 plus 48 equals to 100. So mass of pure CaCO3 equals to mole not 1 into 100, which is equals to 1 gram. This is the mass of pure CaCO3. But when you just read the question one more time, a 1.25 gram of limestone is given, which is the impure form of CaCO3. So now we can work out the percentage purity of pure CaCO3. Okay. Now this is the mass of the pure CaCO3. Guys, always pure mass is less than the impure form. Look at the mass of the pure CaCO3, which is 1. Now percentage purity equals to mass of the pure, which is 100, mass of the pure calcium carbonate, which is 1 gram, and a mass of the impure calcium carbonate, which is limestone, that is given in the question, times by 100. Work out that. Is equals to 80%. That's your answer. So please go through this question for 1 or 2 times. If you did not understand, come back to me. I have done all the question that comes in amount of substances. This is my last video on the amount of substances. Soon I will start chemical bonding in my next video. So guys, if you have any question regarding with empirical formula or the titration, back titration, any kind of question, please come back to me or write your question in the comment box so that I can approach to you. Thanks for watching all my videos on amount of substances. Okay, I will see you soon.